The developer world has been buzzing with a massive rumor. Claude's source code leaked, and we're all about to get a state-of-the-art AI model for free. But that promise is completely false. Right now, there are 3 types of developers reacting to this news. The first type is waiting around for a free lunch. The second type realized it wasn't the actual AI model that leaked, so they ignored it. But you need to be the third type of developer, the investigator who looks at what's spilled out and asks how we can use it. The leak exposed Anthropic's highly secretive agentic workflow, the software engineering framework that sits on top of the LLM brain to guide its every move. A raw language model sitting on a server is practically useless if you want to build a fully functioning application. The real power comes from the invisible software engineering framework wrapped around the AI, guiding it step by step. This chart maps how AI output quality responds to the amount of information you feed it, measured in tokens. Companies advertise massive 1 million token context windows, letting you theoretically feed in entire codebases. But look at what happens in practice. As soon as the data volume crosses that 100,000 mark, the quality of the generated code takes a steep nosedive. The AI forgets instructions, loses the thread, and starts generating errors. Because of this steep drop-off, you can't just type "build me a leak code clone" into a single prompt box and expect it to spit out 20 front-end files, 20 back-end files, and a database schema. The system chokes on its massive output. To get around this physical hardware limitation, engineers had to design agentic systems. Instead of asking for the whole app up front, these systems I built to baby-step the AI through the project, breaking the massive workload down into bite-sized, manageable pieces. Let's trace how Anthropic's leaked architecture actually handles a request. When you ask it to build that leak code clone, your laptop sends your command straight into a central hub called Agent Orchestration. This hub doesn't immediately start writing code. Instead, it parallel processes the request. It drafts a structured plan, designs the overall tech architecture, and then simultaneously assigns specific coding tasks for the front end and back end, splitting the job to save a massive amount of time. But coordinating all those parallel tasks generates a ton of text, which threatens to push the AI over that 100,000 token cliff. To prevent that, the orchestrator relies on what we can call the memory triad. First, the session layer meticulously logs every single prompt, generated script, and failed test in your local system's history. Meanwhile, the auto-trim acts as a live filter. It aggressively snips away outdated or irrelevant conversational context before it reaches the active memory, keeping the payload lean. The most clever piece is the memory.md file. Instead of constantly feeding the AI full pages of previously written code, this file acts like a sticky note. It sends a tiny pointer tag that tells the orchestrator, the database schema is finished and it lives in this exact folder. The AI only reads the full file when it absolutely needs it to write the next component. By utilizing pointers and continuously trimming the fat, the system navigates around the hardware bottleneck. This is exactly how you orchestrate massive applications without ever pushing the model into that messy, degraded state past 100,000 tokens. Once the code is drafted, the agent reaches out to external tools. It functions just like a human developer, running a suite of read, write, and test commands to verify that the newly generated code actually works on your machine before moving to the next step. All of this local orchestration relies on calling the actual AI brain over at Anthropic servers. And right here, a heavy layer of IP protection locks into place, known as Anti-Distillation. When you ask a model to write code, it generates a long chain of step-by-step reasoning to figure out the logic. Competitors want that reasoning data to train and clone their own models. So Anthropic hides the raw logic on their servers behind a secret key, returning only a brief summary and the final code to the user. But the most fascinating capability uncovered in this leak activates after you shut down your laptop for the night. It's a background process called Kairos. While you sleep, Kairos runs scheduled tasks to scan the code you built that day. It identifies inefficiencies, refactors the architecture, and actively optimizes the software without requiring a single manual prompt from you. If Kairos runs into a logic hurdle it can't solve locally, it automatically routes the problem to a slower, higher-tier future model. It will let that model think for 30 minutes to map out a solution, rewrite the app, and leave a push notification on your phone detailing the improvements by morning. This workflow pulls the AI out of the prompt box entirely. It becomes a proactive, autonomous team member instead of a reactive chatbot. So if this agentic architecture is Anthropic's secret sauce, how did independent developers manage to map out the exact workflow? Usually, companies protect their desktop software by shipping minified code. The compiler strips out all the notes and squashes down 500,000 lines of human-readable logic into a chaotic wall of letters and symbols. The software still runs, but nobody can read the underlying engineering. To fix bugs in that mess, developers generate a source map file. This file maps those unreadable letters back to their original function names, like calculate or authenticate. When Anthropic published their command line tool, they made a massive blunder. They accidentally shipped the source map file right inside the public package. It contained live links to their unsecured servers and even included the original source code embedded directly as plain text strings. By shipping that map, Anthropic gave developers the direct link between their production code and their original engineering blueprints, allowing anyone to bypass the obfuscation. The sheer scale of this mistake makes you wonder, was this truly a clumsy accident by a tech giant, or was it a calculated drop designed to build hype around future autonomous features like Kairos? Massive foreign competitors already throw endless resources at reverse engineering minified code. Knowing that, Anthropic likely realized they had very little to lose and a massive wave of developer hype to gain by letting the map slip into public hands. Regardless of how it got out, the lesson for anyone building with AI right now is clear. Sitting at a keyboard and relying on simple, single-shot prompts to build complex software is a dead end. The market is shifting towards AI engineers who build these memory and orchestration systems, leaving simple one-shot prompting behind. The developers who will thrive are the ones who understand how to build systems that do the heavy lifting for them.